important role in our legal system. Now, instead of just collecting fingerprints, we're also collecting saliva, we're collecting blood, we're collecting anything that we can to compare what we found at the crime scene to our suspects. Each segment has a specific length, but all of them share the same repeating sequences of bases or nucleotides. Pretty much how Mark was saying, like ATC, ATC, it's going to be the same. But once it starts changing, that's when it cuts it. Next, they introduce a small set of radioactive markers to the sample. The markers are segments of DNA of known length with bases that complement the code of and bind to sample segments at the same length, like the worksheet that you guys just completed. That's pretty much just one sample. All right, these are the chemicals. You're going to have your DNA, which is what we're going to be comparing. You're going to have your restriction enzymes, the agarose gel, the nylon membrane, the probes, and the X-ray film. The X-ray film is what's going to develop our DNA fingerprint. Each segment has a specific length, but not everyone shares that same repeating segment, which is why one segment might be this long. So we have ATC, ATC that continues 5 or 6 times, and then someone else only has it twice. Chemicals cut those segments at the beginning and the end of those repeating segments, and that's why some are rinsed away and some are the darker. Gel electrophoresis. I know it's a long word, but that's what separates the repeating segments according to their length. It introduces a small set of the radioactive markers, and that's what is the binding and the rinsing away. All right, and then we go ahead and develop it. We send it through photographic film. We use X-rays. This is what darkens. It's exposed to radioactive markers, which is why it is so dark, which is why it's easy to compare. It identifies the location of all marked sample segments, and then it also lines up sample profiles side by side, and we can compare them. The more one has in common with what we found, the more they are most likely the suspect. And that's DNA fingerprinting. Now, we're going to go ahead and do a lab, so if everyone wants to open up the internet. Okay, so who's the culprit?
Honey.
Honey was the culprit. Yep. Do you see how they match up? Everything matches up on it. You pull it over to sugar, not everything matches up.
Yeah.
You pull it over to candy, not everything matches up.
So honey was the definite one?